Are we moving to Mars? The density of the atmosphere on Mars is only 1% of that on the ground. How to fly on Mars? Among the 30 under 30 in science, selected annually by Forbes in North America in 2023, there are 30 scientists under the age of 30. The scientific leader, Shannah Withrow-Masera, is the space power engineer. The density of the atmosphere on Mars is only 1% of that on the ground. How to fly on Mars? It is to redesign the motor, which is faster than the current speed. To fly on Mars. Shannah suggests that our current propulsion systems need to be reevaluated for the Martian environment. Since Mars has a lower gravity than Earth and a thinner atmosphere, traditional propellants and engines may not be as effective. Instead, new technologies need to be developed that are specifically designed for the unique challenges that Mars presents. One possible solution is the use of electric propulsion systems. These types of engines are more energy efficient than traditional chemical rockets, and they can provide a steady, continuous thrust over long distances. This could be particularly useful for missions where a spacecraft needs to maneuver in Mars' low gravity or thin atmosphere. Another consideration is the use of solar sails. These lightweight, flexible materials can be deployed to catch sunlight, effectively turning the spacecraft into a solar-powered vessel. As the sunlight hits the sail, it exerts a small pressure, providing a gentle but constant push. Over time, this can enable the spacecraft to reach high velocities without the need for additional fuel. In addition to propulsion challenges, Shannah also highlights the importance of developing landing systems that can cope with Mars' unique environment. The thin atmosphere means that parachutes may not be as effective at slowing down a spacecraft, so alternative methods need to be considered. One possibility is the use of inflatable heat shields, which can protect the spacecraft during the intense heat of atmospheric entry, while also providing a large surface area to generate drag. This can help to slow the spacecraft down, allowing for a more controlled and gentle landing on the Martian surface. Another approach is to utilize the Martian environment itself to aid in landing. For example, researchers are exploring ways to use Mars' abundant carbon dioxide to create a cushion of gas, effectively turning the spacecraft into a hovercraft that can float above the surface. This could not only help to soften the landing but also enable the spacecraft to travel across the planet more easily. Once on the surface, there are further challenges to overcome. Mars is a dusty, rocky planet with large temperature swings, making it difficult for traditional vehicles to navigate. Shannah emphasizes the need for specialized rovers that can traverse the Martian terrain without getting stuck or damaged. One solution is to design rovers with flexible, articulated wheels that can adapt to the terrain, gripping onto rocks and rolling over obstacles. Another option is to develop hopping or flying drones that can cover larger distances and access hard-to-reach areas. Finally, Shannah highlights the importance of collaboration between different space agencies and private companies. By pooling resources, knowledge, and expertise, we can accelerate our progress towards achieving flight on Mars and ultimately, human exploration of the Red Planet. In conclusion, overcoming the challenges of flight on Mars requires innovation, creativity, and collaboration. By developing new propulsion systems, landing techniques, and surface exploration vehicles, we can unlock the secrets of Mars and pave the way for humanity's future among the stars.